This video is on exercise 9D, the challenge question of A-Level Maths Pure 2 textbook. So this exercise is mostly about the product rule, but it's not only about that, because we also need to use the chain rule and some of the standard, or it's better to say some of the trigonometric differentiations that we learned in the first part. So let's start with part A. As you can see, we have three different functions. So e to the x, sine squared x, and cos x, which is, it's not like the usual product rule type questions that we see where we have two functions. So what should we do? We simply need to take two functions and treat that as a single function being multiplied by another function. So basically we apply product rule twice. That's what we are going to do. So in this question, what I'm going to do is that I'm going to consider sine squared x times cos x as a single function, and e to the x as my second function, or e to the x as my first function, and sine squared times cos x as my second function. Now let's apply the chain rule. So let's apply the product rule. So just to remind you the product rule, so let's say that we have so y is equal to u times v, then dy by dx is equal to, so u and v are some functions that we just named them. Basically, let's write this in this way. So let's say that u of x times v of x, this one is better. Then dy by dx is equal to, so u times dv dx plus v times du dx. Now we can use this, so don't worry too much about the general rule, as long as you for now understand how to use that. That's the good starting point. So now, by using the general rule, let's consider e to the x as our u and sine squared times cos x as v. Then we write dy by dx is equal to, so u times dv dx. U is e to the x times dv dx. Now here is interesting, because for dv dx, which means the derivative of our v, which is sine squared times cos x, we should apply another product rule here, because this is the product of two functions, so we should apply the product rule here. So, and at the same time we should consider one thing, because how can we differentiate sine squared x? So we need to use trigonometric some of the trigonometric formula so that they can help us to simplify this. So we know that the double angle formula for cos 2x, one of them is obviously 1 minus 2 sine squared x. So this is one of them. There are three of these. Now let's rearrange this. Cos 2x minus 1 is equal to minus 2 sine squared x, and divide both sides by minus 2, and you will get sine squared x is equal to a half minus a half cos 2x. So this formula is very useful, especially in integration and differentiation. So now we can, whenever we want to differentiate sine squared x, we simply can differentiate half minus a half cos 2x, because this is much easier. And yeah, so that's what we are going to use. Now let's apply another another product rule inside. So sine squared x is my first function, so I write that down, times the derivative of the second function, which is cos x. So the derivative of cos x is minus sine x. And now I differentiate sine squared x then that times cos x. So sine squared x, by looking at here, so let's differentiate that. So a half differentiates to 0, and then minus a half cos 2x. So 2 comes out, and 2 times minus a half is minus 1. And cos 2x, or cos by itself, cos x, differentiates to minus sine x. Which means that minus sine x with that minus 1, which is outside, they cancel each other out, and we get sine plus sine 2x times cos x. So plus sine 2x is a derivative of sine squared x. Now, what is this? So this is simply the first half of our main product rule. So that's what I have written here is this bit. U times dv dx. So my u is e to the x, and dv dx is the whole thing here. Now let's do the second half, which is v times du dx. So my v is simply sine squared x times cos x. This times du dx. So e to the x differentiates to e to the x again. So my du dx is again e to the x. And that's it. So you can, do some multiplication and simplify this more. Or even you can go further and factorize. But again, I don't suggest that as long as you haven't been asked to do so. Sine squared x times minus sine x is minus sine cube x. And that's plus sine 2x cos x. That's the first half. And for the second half, we have e to the x times sine squared x cos x. Of course, you can simplify this further. You can take a factor of e to the x out. Or even when you are working with functions like here, you can use the double angle formula for sine x, and here you can or even here you don't necessarily need to do anything, but here you can use the double angle formula and then take a factor of e to the x out. So yeah, it's up to you, but I'm not going to do that because the question simply asked for the derivative, and that's it. B, we have x times 4x minus 3 to the power of 6 times 1 minus 4x to the power of 9. So the whole process is very similar to the previous question. So we have 3 functions, and we need to treat 2 of them as a single function, and then we can apply the second product rule for the function for that 2 functions that we treated as a single function. So in this case, we can treat this one as a single function and this as another function. So we write dy by dx is equal to, so in this case, here is our u and this is our v. So for the first part, we do u times dv dx. So our u is x times 4x minus 3 to the power of 6 times our v, which is, sorry, dv dx. So dv dx here is that, so 9 comes down, then inside the bracket differentiates to minus 4, and then we have 1 minus 4x to the power of 8. And now this is our first half, so we have done that. Now the second part is the longer one because we need to apply another product in addition to the main one. So this time we start with v 1 minus 4x to the power of 9 times du dx. So for du dx, first of all, let's write x and then differentiate 4x minus 3 to the power of 6. So that differentiates to 6 comes down, then 4 is the derivative of the inside times 4x minus 3 to the power of 5. And then we differentiate x, and that multiplies 4x minus 3 to the power of 6. And if x differentiates to 1, which is very good here because that's very simple. So 4x minus 3 to the power of 6. And now we can, do some of these multiplications to just, to have a nicer answer. So we have x times 4x minus 3 to the power of 6, and 9 times minus 4, which is minus 36. So we can, write minus 36 here, and then this times 1 minus 4x to the power of 8. And then for the second bit, we have 1 minus 4x to the power of 9 times inside. So inside we have 24x times 4x minus 3 to the power of 5 plus 4x minus 3 to the power of 6. Of course, we can expand the second half and then, do some factorizing, but it's not necessary. That's it for this video. Thank you for watching and good luck.